All right, looks like we've got folks trickling in now. That's good. All right, let's get this thing started. So, I saw two new PRs this week. One was performance improvement for creating mirror snapshots in RBD asynchronously. Jason did a review of that. I haven't looked at it super closely, but it looks like it's moving along. Next, there was a pull review for integrating AVX12 erasure, an AVX 512 erasure coding implementation. I think that's actually just a build change, but Hifu reviewed that. So, not sure if how much of a performance improvement that provides, but I tagged it this morning. So hopefully we'll at some point be able to track that. There were two PRs this week that closed. The first is this librd cache. I think Jason finally thought that was good enough to merge, so that has been merged. I believe that was quite a bit of code, so hopefully we'll be able to harden that and get into a point where folks can use it. But this is the initial PR, so good. What else? This bufferless rebuild one. It looks like that has been replaced, and I did not catch the replacement in this, so I'll get that in here as well. But there's a new PR for that. All right, updated. Adam, if you're here, other Adam. Oh, okay, we don't have core Adam. There's this Blue Store dynamic levels PR that has been there for a little while, and they noticed that it was not behaving properly with Adam's column family sharding work. So I think they are requesting a review. Adam, great.
I guess.
Hey, Adam, I was just talking about this PR that changes or provides initial implementation for doing dynamic leveling in RocksDB, and they've requested a review from you because they said it's not working right with column family sharding, but they think it works right when they don't use it. So they requested a review from you on that.
Oh, thanks. That's interesting.
Sure. Yep. Just if you have time. I know everyone's super busy. Okay. And then the other updated PR I have is just my very, very old now cache binning code. Most of this is actually in master already. That got broken up into multiple separate smaller PRs. But the one remaining piece is the age binning code itself. All of the other things that led up to that are in. So that is now being worked on in a separate branch. I suppose I should probably include that here, but we'll talk about it a little bit more here coming up. So I won't discuss it now. Let's see. So otherwise, there wasn't a whole lot. Adam, I think you've been reviewing Eeyore's changes, but it looks to me like it failed tests. But otherwise, I think you were really happy with it, right?
I'm very happy with Igor's improvements for deleting PGs, especially with the first part, which is really clean and gives much improvement. I'm not so keen to go with the second part, which changes our format and only gives us boost if our PGs do have a lot of OMAP data. That's the only case when the second part really shows its performance boost. But if you have a lot of OMAPs in your PG, then it's like 10 times faster the deletion using the second part. But yeah, I will still would prefer, I think, that when we change a format to extract the change of format to a separate PR and then just make use of it with additional code that takes advantage of it. Yeah, That's it.
Okay. Cool. Okay, let's see what else. Okay, there's your code for making it so that we're more choosy about how we spend our cash for cash shards. And I thought you'd take that with do not merge yet. Is that is that
It still do not merge. It needs to some kind of this. I think should go to the final code, but I guess finally we should first see a cache aging, cache bin aging before actual algorithm for being more aggressive with allocating space to shards should be revised. This is because current implementation, I feel like it will make it very slow for some previously under allocated shards to exit that state to before they in subsequent iteration can get enough pressure to go from a very low. So possibly there
okay?
is some like limit, like 1 megabyte or something should be considered. I've not made a change tests for that, so I cannot provide the numbers. So I left in DNM.
Okay, yeah, it makes sense. Do you have a feeling one way or another about having the cache shards independently compete for age binning and priority cache?
And yes, I'm now considering that this is like making just more elements, more caches without any actual benefits for process of properly allocating sizes to those entities.
Okay, cool. All right, well, I'm sure we'll have more to discuss on that one as we get more results with the testing we've been doing. Okay, let's see. Anything else? I think most of this other stuff is just kind of all waiting in the wings, so not a whole lot of other work here. All right, I think that's about it for PRs, unless I missed anything, guys. All right, well then, Josh, I see PG Autoscaler is the first thing in our list here, so do you want to take us away on it?
Yeah, sure. I wanted to talk about this first since Junior is pretty late for him, so I wanted to get to that earlier. So we talked about this a bunch in the past, and the general idea is so we wanted to improve the out-of-the-box behavior for when you initially install Ceph. You can get good performance from the get-go. So, like the way we talked about doing this in the past was using like the full budget of PGs we have for all the pools to start with, and then only scaling down number of PGs we have when there's pressure from other pools to actually use that and need more space or parallelism. So this essentially means changing the way that the auto-scaling algorithm works. So instead of going up by capacity, it goes it starts with all the PGs allocated and shifts them around if there's a very large difference in utilization later. Like keeping the behavior where it only makes a change to the PGDem if it would differ by a factor of 2. So we don't have any kind of oscillation or small changes. Data movement and is pretty expensive.
So, agreed, 100%. I think that's good. Thing I still don't kind of well, I guess the thing that I keep coming back to is that it seems like we could get some of the benefit by scaling the PG log length rather than reverting back to the autoscaler as kind of the first line of attack. Like the autoscaler is still really good.
Maybe we're already scaling the PG log length dynamically now. It's a per OSD budget for the PG log.
That's
sorry,
the PR I
pool.
shared with you. Yeah.
Yeah, I meant per pool. Oh, it is?
No, that's not. That's for OST. You're
Yeah,
specifically talking per pool.
yeah, exactly. Like instead of first adjusting the number of PGs per pool to control the kind of the distribution of PGs across the OSD, I wonder if it might be lower impact if we started out by scaling the number of PG log entries per pool instead, and then only fell back to adjusting the PG count per pool when things got like really out of whack.
Well, are you thinking of like having a higher like default target per OSD then? I guess I'm confused where the PG log length comes in because that's kind of like a secondary thing where we're controlling memory rather than directly affecting like the amount of parallelism we get.
So I see two separate limitations that prevent us from having more PGs per OSD. One is the amount of memory that we consume for PG log, and then the other is the kind of overhead of just having too many PGs in the cluster in general. There's probably a third thing of like too many PGs per OSD, but I don't think we're actually anywhere close to that yet. I think it's those other two things that really kind of limit us. So it seems to me like we could eliminate some of the problems that we face by implementing a total overall cluster-wide PG count limit. And if we haven't hit that yet, then we're free to kind of have more PGs. And then also scaling the PG log length on a per pool basis so that then you could have more PGs overall in the OSD, but then still scale things back to control memory by scaling the PG log length, right? You're not reducing the overall number of PG entries. You're just changing kind of the dynamics of whether or not you have long PG logs with few PGs in that pool or more PGs in that pool with a shorter log length for that pool.
Then how do you deal with different kinds of pools, like ones that are supposed to consume more? Like just for example, how do you differentiate between a data pool and an index pool in RGW? Do you start out with the same number of PGs and wait to adjust PG log length? So I mean, technically, you'll see different patterns in different pools, right?
Yeah. My
We have that
thought is,
parameter already for autoscale pool bias. So like for metadata pools, we set this to like 4. So today the autoscale uses that to consider them as if they were 4 times their size. I think we could use that in the reverse direction when we're treating things with more PGs, where we say these should be like a quarter of their allocation as then that they would get as if they were a data pool.
Yeah, that could make sense.
my hope is that if we went down this route, we could have enough PGs per pool for a reasonable number of pools that concurrency would no longer be a problem. Like we'd be able to have enough minimum per pool that then concurrency isn't really the problem anymore. It's more about making sure data distribution is good, which we have the balancer for, so hopefully we can not have to worry about that either. I think what we face right now is that if you were to create a large number of pools, either we have so few PGs in each one that we lack concurrency, or we have such a high minimum, like say 16 or 32 PGs per OSD in that pool, with a large number of pools, that you end up with a ton of PGs, and then we end up in situations where, like with containers, the OSD could actually go out of memory.
I think with the memory limits now, they won't go out of memory. They'll just have a much smaller cache. But I think that number of pools is really unrealistic for like a small cluster.
How many pools? Like what do we think is reasonable for like a number of pools for a given cluster?
I'd
Anything
say
close to like 10.
yeah,
10.
10, 20
Yeah.
at order of magnitude.
I'm kind of afraid that that's not going to work in the long run. That we're going to be getting more and more requests for having more pools than that. I mean, we can dictate it, right? We can say, no, this is really the max we can support, but I think
Yeah,
we
I think
could
that's kind
make
of more
it.
the direction we're going. But with we need to have some limits, right? I mean, it's going to be even with a dynamic log length, there's still some minimum we need for dupe detection. So we can't get rid of that memory use entirely. So at some point there needs to be a limit.
But we're not fixing that by having fewer PGs in each pool, right? Like we're hard limited, right? Like you said, 10, as an example. If we have 10 pools that each have a minimum of 32 OSDs per OSD per pool, that's still like 320 OSDs on the, 320 PGs on the OSD. Which, yes, we can make that work right now. In 4 gigabytes, we can shrink the caches a little bit, and I don't remember what that will actually work out to be with our defaults. For PG log length. But I guess my thought was that if we kind of turn this around a little bit, we might be able to support a larger number of pools that then would have, I guess, like you said, it would be shorter overall numbers of dupe entries and PG log entries per pool.
I guess I'm suggesting that that's not a use case that we should be considering. Like we don't need to worry about that use case, I don't think.
Okay. Yeah, as long as we really can just say 10 pools is the like max you can do per cluster. I was just it seems like it could hurt us in the long run. Maybe not.
I think a lot of the things that people think of using pools for could be done with other mechanisms, like with namespaces for multi-tenancy, or with other kinds of groupings for isolation. Like one of the things that Sam has talked about is kind of an overload on top of Crush, where you have like RBD images, for example, using a subset of the cluster, so they're not necessarily spread, even though they're in a given pool. They're spread over like a smaller area within the cluster, so they have a kind of a reduced potential fault area. And this also helps with some other ideas that that's kind of restricting the total number of hosts that need to talk to as well.
One question for you, Josh, related to some of this stuff. This will be my last attempt at this, and then I'll give up on it. But if we have like just completely like cold pools, like no one's been doing anything on it for a while, like RBD hasn't been touched in months or whatever, do we still really need to keep those dupe ops and other PG log entries in memory? Like, does that make sense on a per pool basis to be continuing to keep those around, or can that memory better be used for other things?
That's really not necessary. I'm not sure that that's a very common problem necessarily, but I think that's something that we could solve kind of orthogonally to what we've been talking about.
Okay.
That's kind of more about the like PG log storage and trimming policy.
It also depends, right? I mean, if those PGs that are there on those pools are all active and clean, then probably, we don't need the PG logs as much. But in some scenarios, there are these corner cases where there are unclean PGs, and there we definitely want to keep the PG log around, because whenever you want to use those pools back, you'd need them to recover, right?
Yeah.
Actually, going back to the initial discussion, let us assume for the moment that we don't have more than 10 to 15 pools. What is our current bottleneck, and what can we do to address it? With the SPAC, like whether the SPAC pressure mechanism is the only way to go about it, or is there anything else we need to do?
Like consider like a large cluster, say 100 OSDs, and you just start out by creating some pools. Today, you get a pool with like 32 PGs because that's the minimum. There's no data in it. That's not going to give you anywhere near the spread across all those disks.
I thought we implemented the thing where we scale back, though. I thought that already went in, where we use the ideal number of PGs and then scale it down rather than scaling it up.
No, that doesn't exist yet. That's what juniors.
Oh, okay. I thought that already made it in. Sorry. Okay.
Okay. No.
Okay. So that helps as long as you've got like a couple of pools, right? Like as long as you can just like create a pool with like 100 PGs per OSD starting out, you're great. It's when you've got like 9 already and you're creating the 10th that it doesn't help as much.
I mean, it still helps in that case. You still get, assuming your cluster is large enough to handle that many pools.
You would presumably already be using like some distribution of the available PGs for the other pools, and as soon as you add that 10th, it would then have to steal stuff from the other pools to add PGs for the new one.
And there's a fair amount of wiggle room, like between the 100 target and like the 300 hard limit. There's a lot of space there. So I think we wouldn't necessarily want to be stealing PGs, but in many cases, maybe it's purely adding more.
You'd be really close to your 300 hard limit already with like even just the minimum 32 per OSD per pool with 9 existing, right?
If you're talking about like a very tiny cluster, yeah. I guess I'm more concerned about the larger cluster case.
Okay.
I agree. This isn't really that relevant for like a tiny cluster, where you're going to be constrained by the HW pool using the minimum, and it's going to get the full parallelism because there's not that many OSDs. But for a larger cluster, that's where you really benefit from getting that increased PG num initially, and in that case, you would have enough wiggle room to work with to support adding like a 10th or 11th pool.
Yeah, I'll make it clear. I'm not against any of this. This is absolutely good. More just the worst thing in all of this is the data movement, right?
Yeah, we definitely want to avoid that as much as we can.
Yeah. So anything we can do to avoid data movement is really, I think, a win. However we do that.
Yeah, and you bring up some good points there. I think we're talking also like this PG part, but it's about the way we store PG logs and memory we're using there. We could probably introduce ways to kind of get rid of a lot of that memory usage when it's not necessary. Like we've talked a little bit in the past about like a kind of an LRU type of scheme.
Yeah. I think we're going to have to with how fast. Yeah. We really someday soon are going to need to be able to keep a lot more PG log entries and dupe entries, I think.
Yeah.
And we don't have the memory to do it in memory. Maybe with like Optane or persistent memory. Maybe we get enough addressable space that we can do it then. I don't know.
Yeah, maybe with a very reduced subset memory just for the dupe detection.
Yeah, I mean, you figure if you've got like 32 gigabytes of that, even just available for dupe detection, that gives you a lot more headroom than we have now.
Yeah, definitely.
Junior, sorry, I've been taking up a lot of this conversation. What do you think about all this? Since you're going to be looking at it.
Sorry, I don't know much about PG log, so I don't know. Seems like I'll go with whatever works best. Yeah, I think the autoscaler makes sense, but I'm not familiar with like how it would affect in the long run, or what kind of other use case that it will affect if we were to implement this new algorithm for the PD autoscaler, I guess.
Yeah, I think one I'd like to test with like a kind of artificial maps that like represent kind of real clusters for kind of different use cases and see what the new algorithm aspect would be.
Right.
So like we don't want to get into a situation where we just like use all the PGs for these metadata pools, for example, and then there's like nothing left for the data pools.
Mm-hmm.
As you work on this, just kind of like I said earlier, anything you can do to avoid data movement, I think, is going to be really, really useful and beneficial. So that's kind of the goal with it all is try to avoid having the cluster doing this kind of stuff over and over and over again in the background.
Yeah.
That's why like the small movements are bad, right? Like, adding a PG one at a time, slow over time, constantly rebalancing stuff is kind of a lot of people were complaining about that like a year or two ago when this first was implemented. Is they create a new pool, it gets like 8 PGs or something, and then as they start filling it with data, it's constantly rebalancing and slowing down.
So I guess like just if the target is like 2 times um, the amount of what we need to scale, we just have to, or we can increase it to 3 times. I don't know, so that it avoids like repeating, as Josh was saying.
Yeah, I think we can maybe like test it out like how it would function like if you had like a cluster that was set up originally with like this many pools and then you add a new pool and start filling it up. Like at what point would it start moving things around and uh, we can and we can like see how if that would be like too much movement at this point if we want to change that threshold or what the impact would be. I think the nice thing about this is that the autoscaler is kind of relatively isolated. It doesn't need a whole lot of external stuff, so we can kind of test this algorithm pretty by itself, kind of in a very unit testable way. We don't need to like set up giant clusters to figure out what its behavior is.
Just like plugging in numbers, I guess. Yeah.
Yeah, exactly.
It's pretty easy with the current code to see the impact when you create a new pool and just start like throwing data at it too. Like you'll see it right away with the on and off, the difference between it. So that's like, a good starting point to look at. All right, cool. Anything more on this, guys?
We covered it pretty well. Thanks, Mark.
Oh, thank you. All right. Well, let's move on to ONode memory usage and cache age binning. Adam has been doing tons of work in this area. He fixed a bug in the existing cache code that was preventing us from properly growing the data cache, I believe, buffer cache, and then also got the old implementation of the ONode double caching PR working with column families. And then we also, on top of that, implemented the old cache age binning PR and have all of this kind of working again. Adam, do you want to talk a little bit about what you've seen, and then I can also talk a little bit about what I've seen?
Mark, there is nothing new from my side from last week performance meeting. I've been entirely dedicated to testing Igor's PR and fixing stuff with that. But I can replay what was the result. Basically, when I tested your bundle, meaning that your original PR rebased and also HBinning and also fixes, the limiting factor seemed to be that sizes for KV caches, both O-node cache and regular RocksDB block data cache, just kept growing and they never yielded any data. And I made detailed analysis what are the actual elements in that caches. I mean, not actually what the content is, but evidently RocksDB leaves those entries in our caches. They are just very old. They can be 1 or 2 hours old, even with intensive testing. Only new ones are being used, but the old ones are just there, lying around, and they eat up our space. So that's the most of the new interesting stuff I can add about using caches.
And that was the exact same thing that I saw, Adam. Let me share my screen. So what we have here is a comparison of the different intermediate steps that Adam and I were taking, going through some of these PRs and older code and newer code that we've been working on. And so this first graph is master, and there are some problems in it. The biggest one being that this was before Adam's fix for the data cache. The data cache was not properly growing. But also, we get into a state where basically the meta cache and the KV cache are being distributed equally, even though that's maybe not ideal. And so you can see that like the yellow line and the orange line are almost exactly the same. As we move on through the different code that we did, you can start seeing some changes in this. I'm going to skip over graph number 1 and just go to graph number 2 here. That's with Adam's fix for the data cache, so now it's actually getting more memory, as it should. And then this is also including the O-node double caching fix. So we see that the KV cache is actually much smaller than the meta cache. Now it's much smaller, getting much less memory. The yellow line is much lower than the orange line. Number 3 is where cache age binning is first introduced. In this case, we actually see that the green line and yellow line, this is for the KV O-node cache and the KV cache. Basically, RocksDB's versions of these caches is actually growing, like Adam said, kind of without bound. And it turns out that's all in the first priority level, which is for RocksDB's indexes and filters. Not great. We really want to prioritize caching these things, because if you have a Bloom filter miss, you could potentially be doing a lot of reads for every O-node cache miss that you have in BlueSource cache. It's not good. But it turns out that it looks like RocksDB doesn't actually delete these things. They just wait for them to be expired in the cache. And because we're prioritizing caching these things, they end up getting even more priority than BlueSource O-node cache. They're kind of like the highest priority thing in the current, or in this implementation of the code. And so they just keep growing because they're never deleted. So if we keep going down, scrolling down, I'm actually going to go all the way down to graph 6 here. If we change it so that we don't prioritize RocksDB's indexes and filters in prize 0, and instead we have to compete with all other KV entries in RocksDB's caches, we can eliminate this. So instead of seeing in graph 4 here, this kind of green and yellow line growing and growing and growing, if we have those compete with other KB cache entries, it's too small, or relatively small. And instead, we give a much greater percentage of the cache, the available memory, to onode, which is this orange line. So before, the orange line never exceeded 1 gigabyte. And then in the new version where the indexes and filters compete with other KV entries, and the overall cache is compared to the onode cache, then we see that the onode cache gets much more memory and is actually working a little bit better. Also in these graphs, you can see that everything's kind of working properly. Initially, we don't have a lot of onodes, so data cache gets a lot of memory. That's this teal line, the light blue line. It initially is ramping up quickly during the prefill stage, but then as we add onodes and we grow the onode cache, we start seeing that data cache shrinks and goes down. From some of Adam's testing, I believe he was actually seeing that if he alternated between workloads that had lots of onodes and few onodes, we would see cache memory being given back to data cache, which is kind of exactly what we want in all of this. So I'm hopeful that the code is actually doing what we want it to do. It's just a question of figuring out how to ensure that all of this works well. One thing we do see still in all of this is that tcmalloc very quickly will fragment memory with all of these small objects that we deal with. Creation and deletion, especially in separate threads of all of these small objects. The auto-tuning code more or less works, but as long as we have all of this fragmentation, we see that as soon as the 4K random write workload starts after the prefill stage, the amount of memory available for the cache just plummets down to a very, very low value compared to what it used to be. And then we kind of regrow it here as tcmalloc works things out and maybe helps get rid of some of the fragmentation. But still, we fragment memory terribly in the OSD with all of the objects we create and delete. So if we want to improve this, we probably need to figure out how to avoid this kind of behavior that we currently have.
Mark, I think I will rephrase because that's not very clear. I'm sorry. The problem is that when we had a pressure from a data cache that forced metadata cache to drop some old entries, we did actually see properly metadata cache to drop some onodes. That was very good. But unfortunately, we couldn't get data cache to get the memory because the data left by after using for a metadata, BlueStore metadata, it was so fragmented it couldn't form proper amount of 4 kilobyte blocks for caching. So we were left with less usage of metadata cache, almost the same usage of a block cache, and a lot of unmapped memory from tcmalloc, unused, mapped
Yes.
but unused.
Yes. This is our problem. So Adam, I'm thinking if we can use Radix's implementation of the opportunistic ring buffer for allocating some of these things, maybe we can improve the situation. We can't fix it, but maybe we can sort of make it a little better.
Unfortunately, I am skeptical because I understand that this allocating in ring buffer works very well when we have short-lived objects that we can purge our ring buffer and then reuse it anew. But for the cache, it's just totally opposite. We expect to hold items here for a long time. And more problematically, we modify those elements after they land in our cache.
I propose that we take Radek's work, we make a modified version of it that allocates the ring in chunks. And then if we have a chunk that has some old entries still in it, we set that aside, and then over time we look at the old chunks and we compact them back into the ring if they are only have a couple entries in them.
Mark, I would like to jump in here. So I disagree with Adam's statement that only short-lived object could come from some kind of a pre-allocated free list. I think the concept people need to agree here is that if you know that you can do that many IOPS, it means the amount of items in the system is pretty much constant. I mean, your biggest size, don't think about item machine. You could do, say, 100,000 IOPS. You don't need more than 100,000 objects. So you pre-allocate 100,000 objects, and then you don't need to reshift them. Now, you don't have to pre-allocate the full 100,000. Maybe you do 50,000, which is going to come from the recycle pool. And if you grow more than that, then you might need to do some different allocation. But you could
I'm talking specifically about the LRU cache, though, like
about any kind of object. Any kind of object. If you have, say, you have a task object, you have an active threads doing some kind of IOPS. So every IOPS got some. Did you guys hear me?
Yes.
Yes.
Okay. So I'm saying every IO have some common data structures which are going to be used. So if we could assign them to a pools, and every IO could allocate stuff from the pools, then you have some close estimate of how many objects you need from each type.
I agree with you regarding things for like in-flight objects for IOPS, right? For getting those through. What I agree with Adam, though, that I don't think that we can use the ring as is for long-term storage for LRU cache O-node entries.
So we discussed it in the past, and I raised the concept that every O-node, they have some constant part and some dynamic part. If the constant part will all arrive from a common pool, then you could just keep recycling them. And the dynamic part you could allocate for something like you described, some kind of a body allocation system where you could allocate stuff and it's going power of 2 kind of object. So when you stop using them, you could aggregate them back later.
Well, okay.
Gabby and
Let me explain why I think is the problem. When we store an O-node representation in BlueStore O-node cache, it means it's a set of C++ objects which are linked together by pointers. Some of them are stored in maps, and some are stored in intrusive lists. We do that automatically using default allocator. These elements are spread over different bins in TC allocator. At least I imagine they do. With the proper and their bins are related to their respective sizes. So if I have multiple of those objects loaded consecutively, then I have fully intermixed data from different objects in very close memory regions. And this is why I think we happen with a fragmentation when we arbitrarily delete from cache some objects. We just create a lot of holes, but never continuous regions because we never had a chance.
Adam, what do you think about the idea of modifying the ring buffer to do chunky allocation, and then at some point, if there's not enough entries in the old chunk, then we compact back into the ring?
What does it mean we compact?
So say that you have an old chunk that, because it's LRU cache, there's still some entries there, but they're not very many. Like you have a 64K chunk or 256K chunk or whatever, and maybe now you have like 25 entries that are in it, but it's otherwise empty because it's fragmented empty space. Now we take those entries and we copy them into a new chunk when we create a new chunk. And
Okay,
then
so
eliminate the old one.
Okay, so easiest implementation would be that we have some mechanism that forces all allocations regarding single object to fall into a single bin.
Yeah, exactly. We say that now these entries that were long lived. In fact, maybe we say that these entries that were long-lived, they survived the rotation of the ring. That means that they weren't short-lived entries, now they're long-lived entries. Maybe we put them into different memory space because now we know that they're long-lived. We put them in long-lived storage rather than short-lived storage.
But it requires an active operation.
True. It would require a memory copy. But maybe that's less overhead than dealing with the fragmented space. I don't know. It depends on how many long-lived versus how many short-lived entries we have.
Mark, with all these allocations, do you have an idea of which kinds of objects those are, primarily?
We have some wall clock data showing where we spend time in memory copy and where we spend time creating and deleting things. At least some of it that I've seen in the past has been like the creation of red-black tables and also the creation and destruction of temporary like hash tables.
I think it'd be really interesting if we could map those back to like which objects are using them and see if it would make sense to do some kind of slab allocation for those kinds of objects, perhaps.
Yeah, maybe a more targeted approach like that would make more sense. I don't know.
I mean, a lot of things aren't allocated in bufferless, so I mean, the bufferless recycle thing makes sense for some objects, but not others, right?
Yeah. Some of the things that we probably should try to zero in on are any objects that are created in one thread and deleted in. And I don't have a real great understanding of where we actually do that, but I know it's been talked about in the past. I mean, I would assume that it's related to stuff that we create, like in a TP-OSD-TP thread, and maybe we delete it in the KV-Sync thread, or maybe it's other threads that can do things like that.
I think probably the primary one that we talked about in the past was more about the messenger threads and the like TP-OSD threads or other OSD threads.
Yes, yeah.
Like allocating the buffers off the wire.
Yep. So that's probably something. Oh, go ahead.
And yeah, so I guess that's more about the data buffers in particular, where the reads or writes.
Yeah, that would be a project for somebody to look at. When do we do that? How do we do that? Is there a way we can stop doing it? Adam, I think the fact that you saw that when we do all these O-node creations and then later have fragmented memory so that we can't give it back to buffers, that's key. That was a really good insight that you saw that, because that's kind of what I suspected but didn't have evidence of. So that's really good.
Yes, but I'm thinking that for a second we were talking about a different thing, because I perceive the fragmentation coming from caching and freeing from different threads as totally different topics?
Oh, I think that they are different topics but have the same effect. I think TC-malloc fragments things has multiple ways that memory gets fragmented, but all of it ties back to memory fragmentation.
Oh yes, that's a good insight. I really assume that, never thought about it, but truly if different TPOS DTP handles the update of an object in BlueStore memory, then it will just go from the memory pool of that other thread. So it just adds to fragmentation problem.
So this is a good project for somebody that wants to take it on. I think there's a huge potential for benefit here, but it's going to be tricky and take a long time to get this right.
Yeah, and like we've been discussing several different aspects of it too. Like there's the caching aspect, the fragmentation aspect, to the allocating, deallocating different threads, and the use of like real mempools.
Yeah.
Those are kind of, in some ways independent but projects, but with related effects.
Yeah. The good thing though, right, is that we're actually now starting to get to the point where we're seeing and collecting evidence of this. We're seeing the actual impact of memory fragmentation, and we now have the ability to start kind of actually seeing how bad it really is, and it turns out it's really bad. So it's.
I think it'll also be interesting to see how this works with C star and Crimson when we use the C star allocator instead of TC-malloc. Since that's a kind of per thing, is it still as bad in that case?
Yeah. I need to understand better what Kifu and Sam and the other folks have been doing regarding the how messages come in on the wire and then how that gets distributed to different worker threads. That might play a large part in what we see.
Yeah, I think for the idea is to avoid any kind of inter-thread communication as much as possible. So we shouldn't have the allocate in one thread and deallocate on a different thread problem.
Yeah, we mostly have to avoid that because of the way C-star works. One, we want to share nothing between, or almost nothing between threads.
And does that involve a copy then, from one thread's memory to another thread's memory?
No, they more or less the idea is that one core handles, which is one reactor of C-star, handles everything in one OSD. We didn't yet complete our work on end-to-end or whatever you call it issues, but this is the main.
Okay. I'd like to. I know there's been different proposals over time regarding how that works. I'd like to. Maybe we can spend another whole performance meeting talking about Crimson and what you guys have been doing with it. I definitely enjoy it.
And I think I'm behind on the state of the code now, but Sam Kifu can surely describe what we have and what we know we will do. Cool.
We only have a couple of minutes left, so let's quickly move on. So IOU ring, this has been a topic that's come up really recently. I went back, got kernel 5.9 installed on some of our test nodes, tried to build our code with it. When we include the libiou ring support in Ceph, it doesn't build. it looks like we're trying to use some of the syscalls using a C interface that doesn't exist. Maybe it used to, I don't know. But anyway, if we switch those to syscalls, it works okay. So I don't trust these results that I've gotten yet. I actually am not even quite sure if we're invoking liburing correctly. But the end result is that I don't see any difference, at least in these tests. What I did see, though, when I was doing this, is that the KV sync thread in these tests is like 90 to 92% utilized. And we, again, like we've talked about in the past, I'm seeing that we are spending CPU time and wall clock time doing key comparisons to keep the mem tables ordered. So just more circumstantial evidence, perhaps, that we're spending time in this particular thread doing that, and that may be a limitation that is actually we're hitting before we hit IO submit or other things in libAIO, and thus perhaps are not seeing a difference between IO Uring and libAIO. I have to do more testing. I have to verify that Uring is actually properly being utilized here. But these are the initial results that I'm getting. Hopefully we'll have more next week. Any questions on that? All right, Gabby, I'm afraid that we maybe ran out of time to talk more about pglog this week, but I will put it as the first thing for next week. Does that sound okay?
Okay.
Cool. Anything else, guys, before we wrap up? All right, then. Well, have a great week, everyone, and we'll see you next week. Thanks.